All right. Hello, everybody, to the second Red Team meeting. Today we'll be going over Nmap and doing some service interaction with this lab I have set up, and hopefully it doesn't break because I set it up yesterday and a bit of today. So yeah, if you guys could sign in, take a picture, and I assume most people are connected to the lab already. If not, then I'm going to move over to the next slide and then take a picture. So you can do that while I'm yapping up here. Okay. Okay. If you guys have not connected to the lab, take a picture real quick, and then you can do it later or whenever. We don't you don't necessarily need it right now, but you could follow along with me as I go through some of these demos while I talk about the slides. Okay, so just to review the lab. What you're essentially doing, what you essentially connected to, was a group of machines, a network that I developed, and they have some services, and then we're gonna use it to just do red team stuff, red team practice. My goal for this and for future red team meetings is to have the same lab, but slowly like build it up, so that you guys could still have some familiarity with the machines, but it's not like completely new to you. But we'll keep adding more and more services, more and more vulnerabilities as we go on, and adapting to whatever slides or whatever topics we're going to be covering. Something real cool I'm trying out is doing kind of like a CTF, or just like capturing flags as you go through the systems and follow along. If you guys could go to that link, if you guys are connected to the VPN, if you guys are connected to the lab. Let me do a quick demo. There should be a register button, so make sure you register and log in, and please do not use your main password for any of your accounts. Like, I know we're a security club and stuff, but like you should not be giving me your sensitive information, or any student really. So just write it, like generate a password and write it down somewhere, ideally. And then you guys should be able to see some challenges that I made, and then you guys could, as I go through these slides, you can submit flags and you guys can gain points. I'm not really sure what the reward is for getting the most points just yet, but maybe at the end of the semester or something we could like make something or something. But yeah, if you guys encounter a flag, you can go to challenges, click one, and then paste in the flag, and then you'll get points. Yeah, go ahead.
Downvote button doesn't work.
You gotta do the flag first.
Do the flag first.
So yeah, if you guys didn't like the challenge, downvote it. I'll be kind of sad. But you know, after you submit the flag, you guys can downvote it, or you can upvote it. You can upvote it as well. That's also an option. But yeah. So let's get to the meat of this presentation. So Nmap, how many people have at least used Nmap here? How many people have heard of it? Okay. So Nmap is kind of one of the most essential tools for red teaming, because it's the first thing you kind of do when you get access to a network. It's how you figure out what is on each machine and how many machines there are on the network. So they describe it as a utility for network discovery and security auditing. So this is outside of red team. Some IT professionals also use it to just do inventory on the amount of machines that they have on a network. They use it to check which machines are up, and if it's not up, then they have a problem. But for red team specifically, it's important because we need to know what is on the machine so we can actually pen test them. And we need to know how, and then further on, after using Nmap, we have to also learn how to interact with the service to actually be able to break it. So these are called enumeration interaction specifically. And the primary goal is just to map out the attack surface that we could pen test. And after we map that out, we could narrow it down, and then figure out, just do some pen testing on that one service, and at least you know what they are, the attack surface. So Nmap itself is not complicated, but the background information can be if this is completely new to you. Unfortunately, you have to learn a bit of networking to learn and understand how to use Nmap properly. So I'll just go over the basics of networking in these 2 slides, and hopefully it's not too confusing. But so for a network, right? This is basically how you define or say what a network is. This /24 basically segments this part and this part, which is the network and host section. So, God, it's complicated. A whole network like this would contain the IPs 192.168.1.1 to 2.254. So that would be 254 hosts. You know, the .0 would be kind of like the host identifier, this part, and then the first part would kind of just designate which network it's a part of. Typically, when you're pen testing, you may be given multiple networks, but for this lab, you're only given one. And then this /24 just kind of tells you where does this boundary end for host and network, essentially. Asterisk, because there's some bit stuff that you could do with complicated numbers. So, so to specify a single host or a single machine, asterisk, you would, this cannot be 0, this cannot be 255, the host section. It would be like a number between 1 and 254 if we segment it like this. And then this whole IP address would tell you this is one computer on this network, and this is the ID for that machine, or network ID, your host ID, I guess. Was that complicated?
What if I really want a .0 IP for my machine? I mean,
it'll work. I don't think it will, because it's the, oh, okay.
It's valid.
It'll work if you have a subnet bigger than a /24.
Oh yeah, that's true.
I mean, it'll just work on its own, I'm pretty sure.
Some machines will refuse it.
Well, some will.
The-
I mean, it works technically.
The .0 is there, well, typically in notation, it's there to specify you are specifying a network address, kind of, or a address space. Yeah, great. But yeah, any more questions?
I really want it to be 255.
255. If you really want to know, 255 is the broadcast address. So if you put 255 and you try to ping 255, it's going to ping all of these hosts. But that's just a technical detail if you're into networking and stuff.
Everyone's 255.
Yeah, everyone's 255 technically. And then this is the last part of networking you kind of have to know for Nmap. For each host or for each IP address, they have a series of ports from 1 to 65,535. And then this is basically where services kind of live, or that's how they listen to things. So for a website, you would typically connect to 192.168.1.100, and then you specify the port, which is typically 80 for HTTP. SSH uses 22, and it should be kind of simple. It's just where services kind of listen to connections, and this is how you would kind of represent that or connect to that if you're using something we'll get into. But yeah, any questions? No. Okay, so this is actually Nmap now. Well, we'll go over how to scan networks first, but because we have a big lab that I've set up. But Nmap gets really, really complicated, and I'll show you. Nmap has this really cool thing where it has a lot of options and options and options, and then every time you try to look something up, try to learn how to use Nmap, it just bombards you with all these options, and then you feel like you have to memorize all of them. But worry not. I'll try to keep this as simple as possible, and I will try to keep it the commands that you will need to use just what, I'll just tell you what commands you really need to pay attention to. So the standard Nmap scan is pretty good. It's just sudo nmap 192.168.1.0, and then this would be your network address if you're scanning a whole network. It won't catch everything, but it's a good first scan if you just get a network. So for example, for this lab environment, and feel free to follow along with me. If I do that, it should scan, and then you have to wait for it to scan, and then it should give.
Just ask everyone scanning.
Oh yeah, I did do that. That's true. Okay, well I should have started with the second one, but huh? It will slow down the network really, but it will go through eventually. But okay, well I have an example. Oh wow, that's great. Oh, that's cool. Well, I have an example graphic right here, just in case that would happen. It basically tells you the number of ports, what services are open, and it gives you blocks for each machine. And keep in mind, okay, you may feel confident that you got all of this, and now you can start pen testing. But keep in mind, the default Nmap scan won't catch everything. It's just a good balance between information and speed. So let's go on to the extreme ends. What if you just you don't care about the services it's checking. You just want to kind of have a general idea of what machines are on the network. So hey, that's cool. It did it. But if you just wanted to have a general idea of what machines are on the network, you would do -sn, and that would stand for I don't know what the SN stands for, but apparently it stands for ping scan. So it will just ping every single host that's possible on your network, and then oh wow, that is a long time for a ping scan. Yeah, it just tells you it tells you, oh, these machines are up that we were able to detect with the ping scan. On the extreme end, if you want a bunch of info, and I would not recommend doing this against the whole network, if you look at this side, not that side, because that's slow. If you look at the extreme end, the -A will stand for aggressive, and it basically just tries to gather as much info on the machines as possible by combining a set of flags that we'll get into. But that will take a long time, and I really only recommend doing that against one machine, or ideally just a set of ports on one machine. Please do not do this on the network. It would slow it down immensely.
Yeah, I didn't find anything.
Oh, okay. If you didn't understand what I was talking about with the network, I guess network address and stuff, and you don't really understand the notation, you could also just do a range. And this is also good if it's if you don't have permission to scan the whole network, but you have a certain permission to scan I don't know, 10 to 250 or 20 to 30. You could do that. This is also kind of the same thing. That's slow, but look on here. This is also kind of the same thing, but you're doing it against a specific machine or one machine instead of a whole network. So that'll go faster, and you would typically do it if you, if you can only pen test one machine, if you only have permission to pen test one machine, or if you want to use a certain combination of flags or aggressive flags against just one machine and not the whole network. So an example here would be, okay, I just want to do a standard scan against this one machine because I only have permission to do this one machine. But yeah. So if you're wondering how it works, or I guess you don't have to know it, but I think it's kind of interesting. If you look at how who's familiar with the TCP handshake? Okay, so that's good. It's basically like a 3-sequence handshake where you go from, well, request and then acknowledgement, and then if you ignore this, it would be another request specifying, hey, reconnected. But what Nmap does by default, or if you use the SYN scan parameter, is it actually, instead of doing like a normal like third request or third message, it would actually tell the service, hey, ignore this, ignore it. I'm stopping this connection. So this is kind of the exchange. This is how the exchange would go if a port was open or a service was listening on TCP. If the port was closed, then you would actually get a stop connection from the server. The server will tell you, this port's closed, do not talk to me. And it's called a stealth scan, which by default, it uses a stealth scanning by default because we never actually complete this TCP handshake or this connection. So services will typically not kind of log it because you never actually like connected to the, you never actually completed a connection to the machine. And you usually, it's like lower in the, I guess, stack or whatever. Like the service won't even know about it. But if someone is monitoring, or if you have a intrusion detection system on your network, this will most likely catch this, and then you can tell, hey, this guy's probably trying to scan our network, and you know, the blue teams or whoever will be alerted. Any questions?
So we can actually get some information from that Nmap, right? When some of them don't know, when the server don't know.
Yeah. So if like, you're right. So for SSH example, actually I'm not too sure, but I'm pretty sure SSH will only kind of log until you make that connection. And if you never actually complete the connection, because we did that reset with Nmap, it won't log it, and you know, it'll be kind of hidden. That's why it's called stealth. All good. So this is like kind of a underutilized version, underutilized feature of Nmap, scripts, and I'll go over one of them. Hopefully it will work as people are Nmapping my network. So 103, and we'll do, if you look at the slides here, we'll do default scripts, and that's generally good enough for a lot of initial, I guess, enumeration. Now, while it's going, I'll yap about this. So this actually interacts with the service by doing like a set of like instructions, and the idea is you're supposed to get more information out of the service for a lot of these scripts, and some of these scripts can actually like take down the service or even exploit it for you, get you a shell. So if it's like really vulnerable and it's really well known, so you can invoke that with this this parameter, and this is just a set of like categories that they let you use. But yeah, I do have to say, DOS, exploit, intrusive, those are, well, they are what they say they are, and they're kind of dangerous. Well, dangerous in the fact that it could take down the system, it could be a bit unstable, and it may not entirely be like allowed for you to use depending on the pen test scenario. DOS specifically, which is denial of service, could take down a service, and that would be kind of bad if you're doing it against a real company network, and that company relies on that service. So yeah, just be careful with what scripts you do use, and if you want to be extra safe, you would specify, hey, I only want safe scripts. The Vuln one is also pretty good. I'm not sure if that would take down the service, but I'm pretty sure it's just passive vulnerability scanning with Nmap. So yeah. Any questions?
I just got rickrolled.
Okay, we'll get
Terminal.
we'll get into that. Something you have to note with Nmap. By default, Windows will not respond to ping scans. So oh, I cleared it. Oh, actually, no, I didn't clear it. But if you check out this scan report I did earlier, I know there's a Windows machine on here. I put. I'm sorry. Yeah. Okay. There is a Windows machine on here. You're right. But it actually doesn't show up on my Nmap report, and that's because what Nmap does to speed up scanning is it first does a ping scan. So it will first do a -sn and just figure out, hey, these are on the network. And then it will do more enumeration on top of that. The problem is Windows doesn't respond to pings by default for security or I don't know, to make our lives harder. So you will have to do something else. You'll have to basically tell Nmap, just focus on here. Tell Nmap, treat the host as up. Treat it as if like the host is up, and just do the port scanning first, and don't do a ping scan to check, to make your Nmap scan faster. Just try to connect to all the ports, even if it could be down. I don't have a. You may also see a port as filtered, and I actually didn't get that on here. And that's different from the state being open, and well, typically with an Nmap scan, you would see the state being open or the state being closed, and that's normal. If you see as filtered, that's kind of annoying because it likely means that the port is actually just firewalled off. So you won't really know. Oh yeah, go ahead.
Oh, I was just gonna say, filter doesn't show up in the scan because it takes the largest category of ports and it puts them like at the bottom that says all the rest of the ports we found were filtered.
Okay.
So there's like a small line of text at the bottom that'll say that the rest of the ports are filtered.
Oh. Yeah. Okay. I didn't see that there, but I think you're right. But anyway, if it's firewalled off, you don't get this response back, or you don't even get this reset. So we can't tell if the service is up or down. We can't even communicate with the machine in terms of like connecting to its ports or connecting to its services. So that's why Nmap shows as filtered, because something could be listening on it, but we don't know because something else is blocking it. Either the machine has a firewall set, or there's a router in between, and it's like detecting your connection as, the network administrator would have rules that say you can't use these ports to connect, or even an IDS would try to stop you if you have the pattern of having like a malicious connection or something like port scanning. Some IDSs will detect if you are port scanning just because of how Nmap is very like algorithmic, and it checks every single port one after the other kind of fast. It will detect, an IDS would detect this is happening and be like, hey, I don't want you to do this because you may, find out information about the network I don't want you to know, and it would just start blocking all of your connections. Any questions? And this is just an info dump with some of the flags I didn't go over. You have OS detection with -O. This is an O, not a 0. You have version detection with -SV. Yeah.
Sorry, a question about the Windows ping.
Yeah.
last year in CPTC, did they? I know certain competitions will enable pinging even on like Windows Home or Pro, whatever installations, just to like be more like beginner friendly, I guess. Do you have to actually like do a ignore pings option on at last year's CPTC?
I didn't do last year's CPTC, but
we didn't have to do that because the firewall was disabled.
Because of firewall. Okay.
It only allows pings if the firewall is on.
Oh, if the Windows firewall is on.
Yeah.
Oh.
Well, even if that did happen, like a network administrator would enable pings on all the machines, you can't really be too sure. Like you don't really know if it's like, oh, some of the machines or all of the machines unless they explicitly tell you. So, well, what my methodology would be is first do an uptime check, do a standard scan, and then afterwards you could try doing a longer scan, or so a scan that would take a longer time, which would be scanning for Windows without the with -pn by treating all the hosts as up, which would take a lot longer. Oh, something very important. This is a pretty important port option is -p, and don't be pressured if you can't memorize all of this, because I know I had to look a lot of this up. But -p will basically just tell Nmap scan this port, or if you do -p-, it will scan all the ports. And then if you scan all the ports, you can be pretty confident that you know all the services that are on a machine or that machine is listening with. Top ports is very useful. If you don't want to wait for -p-, which could take a long time, I would use top ports and put it to like 1,000 or 2,000, and that will just be the most common ports. So that would be like SSH, FTP, DNS, web, and a bunch of other ones. And typically, you can't be too sure that you got all the services, but you can be pretty confident, hey, these are the these are the services that are up, and what could be is part of the attack service. You could save the output to a file in case you clear your terminal, and just something good to do just in case you do clear your terminal and you don't want to have to run that Nmap scan again, which could be pretty aggressive and take a long time. So you want to save that output. You could explain why a port is in a particular state, or you could do, as mentioned before, an aggressive scan, which kind of just combines these two. If you put these two, it's basically the same as doing a -a. And of course, you could see Nmap's progress if you click spacebar at any time that the program is running. This is a fun command, so I'll have you do that if you want. It's a machine. And if this scares you, that's okay. There is a official GUI called Nmap. I haven't used it, but it should be pretty sufficient for some pen test scenarios. You got something to say, Andre? Or Nmap is
Nmap is the best. There's another one that I've seen people use where it's Nmap but in Rust
scan,
yeah.
Right?
Apparently that's supposed to be good, but in my experience it's been pretty bad.
Yeah.
It's like default Nmap.
Default Nmap is great. But yeah. Something I have to point out while I'm going over Nmap, please do not use it on any UF machines or if you're on the network, do not use it against anything on the internet, because that's against UF policy, and UFIT will give you a stern email. I know this one specifically, it was actually, I think it was part of a class. I took it from the UFSIT Discord, but it's part of a class where the assignment was to use Nmap for an assignment or something. And then the folks at UFIT or UF InfoSec compliance didn't like that because it's a lot of traffic going for potentially malicious, I guess, purposes. So I guess they just ban it entirely. But since you guys are connected to a VPN and on our machines, we should be fine. Or if you create a local virtual machine network, if you like setting up home labs and stuff through VMs, you should also be fine because then your traffic will not leak anywhere outside of your, thing, hopefully. Most importantly, we haven't got any complaints about it. So yeah, you should be fine. Also, outside the UF network, you may be asking about legality because you are like kind of you're kind of putting a lot of traffic and load to a specific, I guess, host. So if you do it against any like public infrastructure, like the internet, or like any machine on the internet, it's kind of a gray area depending on what you do, and just be careful. Port scanning itself is not a crime from what I could find against any public machines. But again, I'm not a lawyer, so don't point at me. But I also heard some stories where it may be against your ISP's policy, so they could cut your internet from that, or maybe they could give you fines, I think. So if it's against your ISP policy, they will probably contact you and before they cut off internet. But still, if you have a friendly ISP, you should be fine. And UF, especially, no, don't do it. And while port scanning itself is not a crime, at least I don't think, aggressive scanning could also cause things to crash because you are overloading. You could overload a service with too many requests, and that would be basically a denial of service, which is illegal. And some Nmap scripts, which I talked about, has an auto-pwn feature or an exploit feature. So you don't want to do that and get a shell and then have their, I guess, legal team go after you. And yeah. So we're going to go over, well, I just have this up here, but this is basically how I do my service enumeration with Nmap. Just initial host discovery, and then I try to focus on one machine afterwards, and then just try to figure out what are the most important ports that are open on that machine, what services are up. And I would typically do that with a -F for a fast scan or a -- top ports if I don't get much out of the -F, I would increase the top ports by more and more. And then after looking at some of the services, maybe I get stuck and try to do a more thorough port scan, which would be, you should use the -P- option and scan all the ports, and I can be pretty confident, hey, I know all the services that are kind of on that machine that are listening. And then after that, we can try getting more information from the services by using -A, using default scripts, or specifying a specific category of scripts if I think that the machine is extremely vulnerable and Nmap is capable of pwning the machine for me, which would be very useful. That's about it for my slides. I have this cool the network. If you guys have been doing it while I've been yapping up here, if you look at the challenges, I have a certain set of challenges here, and basically, as you go through Nmap, as you go through Nmap, you're able to find services again, right? And then what I want you to do is just try to interact with some of the services. Try to find the flags on the machine, and you can get points on this website that's on this IP address. So make sure you sign up to the CTFD website and try to do some of these flags, and kind of excited to see how much you guys find. But yeah, I'll give you an example. For SSH, well, I see SSH is up for 102 and 103, and I'm going to try to do SSH 102.168.101.102, and then it gives me a banner and stuff, and then, well, I don't know the password, so, well, I don't know the password, but, just try to enumerate and try to get access to the machines. Some of the machines aren't completely vulnerable, but this is just a test to see, can you interact with services, and can you use Nmap to find what services are on the machine? So Good luck, and I'll check in with you guys later.